Hello, this is Dr. Hanaa Assil, and this is the second part of the organic chemistry. So we're going to talk about physical and chemical properties, reactions of alkanes, alkenes, alcohols, carboxylic acids. So first of all, you should remember that alkanes with small number of carbons are usually gases. So we have methane, ethane, propane, butane. These are all gases. Now, when we come to 5 carbon atoms and above, they become liquids or solids. So alkanes are usually gases when we have the lower number of carbons. Uses, what do we use methane for? You should know that methane is an alkane. It is the main constituent of natural gas. So when he says natural gas is what? Natural gas is methane. Now, what do we use it for? We use it as a fuel. What about ethene? Ethene is an alkene. What do we use it for? We're going to say we use it to make ethanol and to make polymers. And we'll talk about that in a minute. Uses of ethanol. What do we use ethanol for? Ethanol is a fuel and it can be used as solvent. It is also what we call beer, and it can be used to make perfumes. Okay, reactions. We're going to say that one main reaction of alkanes, alkenes, and alcohols is combustion. So you have to remember that combustion is burning. Now we have two types of combustion. We can either do combustion in excess oxygen, so we call that complete combustion. So if he says we're doing complete combustion of any of them, alkanes, alkenes, alcohols, first of all, we're reacting it with what? Combustion means burning in oxygen. So we're reacting it with oxygen. Now, what should it give you? It doesn't matter whatever I'm starting with. Complete combustion, excess oxygen will give carbon dioxide plus water. Incomplete combustion means I'm burning the alkane or alkene or alcohol in lack of oxygen. That will give carbon monoxide plus water. And then you balance depending on what you're starting with. Are we okay? So combustion, burning means reaction with oxygen. If it is a lot of oxygen, then it will give carbon dioxide plus water. If we're burning it in lack of oxygen, or we say limited oxygen, or it's called incomplete combustion, then what we get is carbon monoxide plus water. And the problem with carbon monoxide, or the hazard of carbon monoxide, is that it is poisonous or toxic. Substitution reactions of alkanes. Now you have to remember, alkanes do which kind of reaction? They do substitution reaction. And substitution reaction needs light. So in order to have this reaction happening, I need to give it UV light. So if we say what are the conditions for substitution of alkanes, the condition is UV light. Now, any reaction that needs light is referred to as a photochemical reaction. So this is an example of a photochemical reaction because it's a reaction that requires light. Now, what are we doing here? Remember, substitution means I'm starting with alkane. It's only for alkanes, not for alkenes or alcohols or any other. It's alkane reacting with a halogen. So you should remember that halogens are fluorine, chlorine, bromine, iodine. Fluorine is too reactive. We usually don't do reactions with fluorine because it is too reactive. We don't do reactions with iodine because it's much less reactive. So the ones that are reasonably reactive are chlorine and bromine. When we react alkane with chlorine or bromine, this is called substitution reaction. And what happens is one of the hydrogens anywhere in the alkane is removed and replaced with one of the halogen. So I'm starting with CH4. I will end with CH3Cl. So the word substitution means replacing one atom by another. So the substitution reaction of alkanes, we're going to replace one of the hydrogens with a chlorine. And that means I am left with the hydrogen that I removed and the other chlorine from the Cl2. So my other product is HCl. Again, if I am reacting this alkane, do you remember the name of this alkane? This alkane is something that has 3 carbons. So I'm starting here with propane. Now, when we react propane plus bromine, first of all, if he asks what are the conditions, UV light. UV light allows this reaction to happen. What is going to happen? We said substitution means I'm going to remove one of the hydrogens and put one Br instead of it. And that means my other product is HBr. But then I have two choices actually. I could either put the bromines on one end, either this end or that end, or in the middle. So these are actually two different products. If my bromine is on one end, how do I call it? We said when we name this kind of compound, this is 3 carbons, prop. It has only single bonds, ane. Now it has a bromine, so it has bromo. Now the bromo is on which carbon? Remember we said we count from the side that gives the lower number of carbons. So I'm going to count from the right to, in that case, my compound here is 1 bromopropane. What about that other one? What would it be called? 2 bromopropane. Okay. Another reaction of alkanes is cracking. And you should remember that cracking is breakdown of long chain hydrocarbons into shorter chains. So cracking in English means breaking up. So we're breaking a long chain hydrocarbon shorter chains. So if I start with, for example, something that has 8 carbons, and I want to break it up. First of all, what are the conditions for cracking? Please learn the conditions for each of these reactions. What are the conditions for cracking? Conditions for cracking is aluminium oxide catalyst and very high temperature. So it's 400 to 700 degrees Celsius. This will break the long chain into several parts. One of them at least has to be an alkene. So cracking must give you an alkene. So let us say that I start with CH18. I'm going to break it up into ethene. Ethene is something that has C2. What is the rest of the molecule? If I have C8, I remove 2 carbons, so I'm left with C6. I had H18, I removed 4 hydrogens, I'm left with H14. So usually he will give you one of the products and ask you to complete the equation. It is just the rest of what I started with. So cracking will give either alkene plus alkane or alkene plus hydrogen. And this is actually how we manufacture hydrogen. This is where they get hydrogen gas from cracking of hydrocarbons. Okay? If we talk about alkenes, again, alkenes will do combustion just like alkanes. We said in presence of excess oxygen, it gives carbon dioxide plus water. In lack of oxygen, it does incomplete combustion and I get carbon monoxide plus water, which is a poisonous gas. Carbon monoxide is a poisonous or a toxic gas because actually it attaches to the hemoglobin in the red blood cells, and you should know that the red blood cells are supposed to transport oxygen. So if there is carbon monoxide, they are transporting the carbon monoxide instead of the oxygen, so less oxygen goes to the body cells. Okay, we said alkane do substitution, but alkenes do addition. What do we mean by addition? We mean I'm starting with an alkene, so that has a double bond. Well, what am I reacting it with? Well, whatever I'm going to react it with. I look at the 2 carbons that have the double bond. I'm going to copy them with a single bond, and then I'm going to put something on that carbon and something on the other carbon. So let's say I'm starting with propene and I react it with bromine. Bromine means I will change the double bond into single bond, put a Br on this carbon and a Br on the other carbon. What if I'm reacting it with hydrogen? And please remember that when we react it with hydrogen, we need a nickel catalyst. So that is the condition of the reaction. We react it with hydrogen. What are the conditions? Nickel catalyst. Again, the two carbons that have the double bond will be single. And we put hydrogen here and hydrogen on the other carbon. If I react it with HCl, hydrogen on one carbon, Cl on the other. What if I react it with water? Alkenes with water, the double bond still opens up, becomes single, but on one carbon I'm going to put an H, on the other carbon I put an OH. So actually when you add water to alkenes, what you get is an alcohol. And you have to know the conditions of adding water to alkenes or hydration of alkenes. You need phosphoric acid catalyst and 300 degrees Celsius. Are we following? Phosphoric acid catalyst and 300 degrees Celsius. Okay, remember that the test for alkenes was what? You should remember that the difference between alkenes and alkanes is that alkenes are unsaturated. They have a C double bond C. Alkanes are saturated. They have single bonds. What was test for alkenes? Add bromine water. With the alkenes, the color changes from reddish brown to colorless, or we said from orange to colorless. With anything else, no change. So if he's trying to distinguish between alkenes and anything else, then the alkenes will react with bromine water, change from reddish brown to colorless. Alkanes, no change. This is because with the double bond, we said we open the double bond, we put a Br on one side and a Br on the other, so the reddish brown color of the Br2 disappears. So if he says describe a chemical test used to distinguish between unsaturated and saturated hydrocarbons, what did we just say? Our test would be add bromine water. With unsaturated, which is alkene, the solution turns from orange to colorless or reddish brown to colorless. With saturated alkanes, no change. This is another typical question on what we're talking about. So when methane burns, it reacts with a gas in the air. Remember, we said combustion means it's going to react with which gas? Oxygen. Now name the two substances that form when methane burns in plenty of air or lots of air. Remember that any alkane, alkene, alcohol. In presence of lots of air, then what you form is carbon dioxide and water. Name the poisonous gas that forms when methane burns in shortage of air. We said shortage of air or lack of air. We said what do we get? We get carbon monoxide and water. Okay, this is another question where we have cyclopropane. Can you see the cyclic compound? We said when we draw cyclic, this is how we draw it. Each carbon still has to have a total of 4 bonds. So he's saying this is the displayed formula for cyclopropane. Draw a displayed formula for cyclobutane. What do you think the cyclobutane would look like? We said this is how a cyclo compound looks like. And remember that cycloalkanes do the same reactions as alkanes. So he's saying the reaction between cyclopropane and bromine is similar to that between methane and bromine. One product of the reaction between cyclopropane and bromine is hydrogen bromide. State the condition required for this reaction. What are the conditions? Remember, cyclopropane is an alkane. And we said when alkanes react with bromine, what are the conditions? It's a substitution reaction, and the conditions are UV light. You have to remember, conditions for substitution reaction is UV light. Complete the displayed formula for the other product of this reaction. Now, when cyclopropane, which looks something like this, but it has hydrogen, when it reacts with bromine in presence of UV light, this is just like the normal alkanes. We said this is substitution reaction. What happens? We're going to remove one of the hydrogens, any one of them, and replace it with a Br. So this is the product you get, whether we're talking about cyclic or normal straight chain alkanes. Okay, ethanol is an alcohol, and you're required to know how are we going to prepare ethanol. This is because ethanol is an important product that is used for many things. So let's see how we're going to prepare ethanol. We have two methods to prepare ethanol. One method is from ethene. Remember we said if I have an alkene and I add water, phosphoric acid catalyst, 300 degrees Celsius, please notice the conditions. This opens up the double bond, puts H on one end, OH on the other carbon. This is called hydration of alkenes. So this method is hydration of alkenes. So this is one method of making ethanol. And of course, one advantage of this method is that if you have ethene and you add water, you directly get only ethanol. So this is a fast process and it gives a pure product. So it just gives ethanol. You don't need to do any purification method. But the question is, where are we going to get ethene from? Remember, we get ethene from petroleum. Remember, all organic compounds come from petroleum. Petroleum is a mixture of liquids. How do we separate a mixture of liquids? We do fractional distillation. So the petroleum, we do fractional distillation, we get a mixture, different liquids. Now we can take these liquids which usually have long chains and do cracking. Do you remember what was cracking? Cracking is when we add aluminum oxide catalyst, high temperature, 400, 700 degrees Celsius, and it breaks up the long chain to give shorter chains. Usually it ends up with ethene. So one disadvantage of this process is that I need to get it from petroleum, and petroleum is a non-renewable resource. You remember that? Petroleum is something that will eventually run out. We're not making more petroleum as fast as we're using it. So we call it non-renewable resource. So that is an advantage, disadvantage. Sorry. Another disadvantage is the fact that I need to do hydration at very high temperature. I need to heat it to 300 degrees Celsius, and this needs energy, so this is expensive. Another method of making ethanol is making it from glucose. Remember, glucose is C6H12O6. Now, if I do what we call fermentation, I add yeast, water, 37 degrees Celsius, this will change the glucose to ethanol. But the disadvantage of this process is that this is a slow process. This will take several hours before the yeast changes the glucose to ethanol. And then at the end, I don't just have ethanol. At the end, I have a mixture of yeast and ethanol and water. Yeast is a solid, so I can separate it by filtration. But then I will end up with a mixture of water and ethanol. These are mixture of liquids, so I have to do fractional distillation. So the disadvantage of fermentation is that it's slow and the product needs to be purified. But one advantage is that where do we get glucose from? I can get glucose from sugarcane, and sugarcane is something that I can grow, so it is renewable resource. So the advantage of fermentation is glucose is obtained from sugarcane, which is a renewable resource, and the reaction happens at 37 degrees Celsius, less energy needed, so it is less expensive or cheaper. Are we following? So the advantages of the two methods, please be familiar with it. Hydration is when I add water to ethene. It produces pure product, faster process. It does not produce carbon dioxide, so it will not contribute to the greenhouse effect. But the disadvantage of hydration of ethene is that it needs crude oil. This is a non-renewable resource, and it requires high temperature, so it is more expensive. The fermentation of glucose. Advantages: glucose is obtained from sugar cane. This is renewable. It works at room temperature and pressure, so it is less expensive. But the disadvantage is that it's a slow process and the product needs to be purified, and it also actually produces carbon dioxide gas. Remember that fermentation will give ethanol plus carbon dioxide. So it produces carbon dioxide gas that causes greenhouse effect. Please be familiar with all of this. Reactions of ethanol. Again, ethanol does the combustion that all the others, alkanes and alkenes, do. Again, complete will give carbon dioxide and water. Incomplete will give carbon monoxide plus water. But the other reaction of ethanol is oxidation reaction. So you remember that an oxidizing agent could be potassium permanganate, KMnO4, or potassium dichromate, K2Cr2 or 7. So the conditions for oxidation of an alcohol. First of all, we need acid. We need concentrated sulfuric acid. And then I can use potassium permanganate. Remember, in that case, potassium permanganate will change from what to what? From purple to color. Or I could use potassium dichromate, and you should remember that potassium dichromate would change from orange to green. So either of these will change the alcohol to the corresponding acid. So if I oxidize ethanol, it gives ethanoic acid, propanol, propanoic acid, and so on. Or you should also remember that I can do oxidation using bacteria. So if we have bacteria, it can do oxidation, for example, during the production of vinegar. This will change the alcohol to acid. Okay. Another reaction of acids, remember that carboxylic acids do the same reactions as the normal acids. You remember reactions of acids and bases? We said acids can react with what? It can react with metals. So in that case, it's supposed to be give a salt plus hydrogen gas. Now remember that the carboxylic acid, we remove the H of the COOH. So if I'm reacting with Na, we remove the H of the COOH and put Na. In that case, the product is called sodium ethanoate. If it's starting from ethanoic acid, then my product is sodium ethanoate plus hydrogen. Or the same, if I remember that we said we remove the H and we put the Na. Or if we put calcium with an acid, also we're removing the H of the COOH. So it had COOH, we're removing that H and we're putting calcium. Of course, calcium has a valency of 2, so I need 2 of the acid molecules. And again, my other product is hydrogen gas. Are we following? Acid with metal gives hydrogen gas. If we're talking about carboxylic acid, then it will give the OH. The salt will be called something OH. So sodium ethanoate, calcium ethanoate, and so on. Okay, again, acids react with bases to give salt plus water. Also, carboxylic acids will do the same. So if I'm starting with ethanoic acid, again, we said we're going to remove that acid of the COOH, put the metal, that's my salt, sodium ethanoate, but remember that acid plus base will give salt plus water. So in this case, my other product is H2O. Also, you know that acids react with carbonates. And we said acid, when we talked about acids and bases, acid reacts with carbonate to give salt plus carbon dioxide plus water. The same for carboxylic acids. I have ethanoic. We said the salt will be called sodium ethanoate by removal of the hydrogen from the COOH. Can you see that? Plus what? Plus carbon dioxide plus water. Are we following? Okay, the other important reaction is a reaction of acid with alcohol to form ester. Remember, acid plus base gives a salt plus water. Now, carboxylic acids react with alcohols. They will give what comes out is called an ester plus water. So in this case, if I have an acid, carboxylic acid, it has C double bond OH, and the alcohol has an H. So I remove the OH of the acid, remove the H from the alcohol, and what comes out from joining these two is called an ester, and I removed a molecule of H2. Following, let's try again. If I start with ethanoic acid, so this has to be reaction of acid plus alcohol. So if we say we're reacting ethanoic acid with ethanol, what is the product? Remember, it's easier to draw it as I'm going to explain. So you draw the part from the acid first. So I'm starting with ethanoic, so I have CH3, C double bond O. And then I remove, we said we remove the OH from the acid and remove the H from the alcohol and put it so that they are joined together. So instead of C double bond O OH, it is C double bond O and the part from the alcohol OC2H5. Can you see how we drew it? We said, of course, that the conditions here are concentrated sulfuric acid, and the other product, because I removed OH and H, then the other product is what? Now, how do we name the product? We said the product is an ester. How do we name esters? We start with the name of whichever alcohol I am using. So we use which alcohol? Ethanol. My ester is called ethyl something. Now, what was my acid? My acid was ethanoic. Then the ester is called ethanoate. Can you see that? Let's try again. I want to react propanoic acid with ethanol. Now, what did we do? We said we're going to draw the acid. C with 3 H's, C with 2 H's, C double bond O, and remove that OH. And remove the H from the alcohol and join them together. So I end up with that product, plus water, of course. Now, how do we name the product? We said the product started from alcohol. Can you see which part is alcohol? It's the part OC2H5 in the product. So that was ethanol. So the name must start with ethyl something. What was the name of the acid? Propanoic acid. So my product is propanoate. Are we following? Again, let's try naming esters. So we said esters are made from alcohols and acids. Which part was, if he draws this as an ester, which part was the alcohol and which part was the acid? Remember the part that is with a red box there? That was the alcohol. The part after C double bond OO something, that was the alcohol. Now, the part in the blue box, that was the acid, the part that has the C double bond O something. So, the alcohol is the one on the right. How many carbons? 1. So that means I started with methanol. So my name should be methyl something. Then the part on the left, that was the acid. Now, the acid here had how many carbons? 2 carbons. That means I started with ethanoic acid. So my ester should be ethanoate. Again, let's try naming this ester. Where is the alcohol? The part with the red box. The part after the C double bond O, that the part after that, that's the alcohol. It was an alcohol that had how many carbons? 2 carbons. That means my name is ethyl something. Then the part that had the C double bond O, the one with the blue box, it had only 1 carbon. That means my acid had only 1 carbon. So that was methanoic acid. So the ester should be methanoate. Try naming this. Where is the alcohol and where is the acid part? The alcohol part on the right, 2 carbons, ethyl. The acid part on the left, again 2 carbons, so that was ethanoic, so it is now ethanoate. This one is what? This one would be ethyl butanoate. Are we better at naming esters? Okay. Uses of esters. Remember that esters have a fruity smell, so they are used as food flavorings and they are used in perfumes. So we're going to stop here for this part. We still have to do polymers, but we will do that in the next video. I hope you understand these reactions so far, and next time we're going to talk about polymers and polymerization. Thank you for listening.